All right, lesson 1.12, transformations of functions. Our skills and learning objectives are to use transformations of functions to graph polynomial and rational functions, and we're going to construct a function that has a specific additive and or multiplicative transformations. All right, so in lesson 12a, says the simplest form in a set of functions that form a family, namely f of x equals a times f of b, x minus h plus k, is commonly called the parent function. A change made to at least one of the values, a, b, h, and k, is called a transformation. There are four types of transformations: dilation, reflection, rotation, and translation. So we start out talking about our rigid transformations. Here, a rigid transformation, it keeps the original shape and size of the graph unchanged. And so the notation here is, notice that, well, first thing, it talks about the k there. Under notation, you notice it's g of x, the first two, is equal to f of x, and it's either plus k or minus k. K is right there at the end of the equation. It is not inside with x, therefore it will affect our y values. So one time we got this k here, and that k, they're not inside with x, they're going to affect the y values. They're being added or subtracted, which means it's a translation. Since it affects our y values, they're going to be vertical. They're being added or subtracted, so it's a translation. And if it's a positive k, it's going to go up k units. And if it's a negative k, it's going to go down k units. So they're going to affect my y. So my x's are going to stay unchanged. And if they're going up, we said that's going to be, we're going to add. And if it's going down, we will subtract k. All right, then the next two, notice is the h. And so I'm going to have to erase what I have there. And so notice that h is inside with x. So because it's inside with x, that means it's going to affect the x-axis, which is our horizontal. It's also being added or subtracted, so therefore it's going to be a translation as well. So let me scroll up. All right, so because h is inside with x, we know it's inside with x, so it's horizontal. It's being added or subtracted, so it's a translation. Now, everything that's inside with x always does the opposite of what it's supposed to do. So this says minus h, so you think you would go over to negative h, but you don't. You're going to go to the right h units. If it says plus h, you're going to go the opposite than your positive numbers. You're going to go to the left h units. And so for our ordered pairs, if it says x minus h, remember it's going to do the opposite. So we're going to add h to our x's, and the y's will stay the same. And if it says x plus h, we're going to subtract h from our x's, and our y's will stay the same. Now, since I scrolled up, I'm just going to write this other real quick. So this was x, y plus k, and this was x, y minus k. All right, and then the last ones they gave here under the rigid transformations is the reflections. So remember, this says negative f of x is the same thing as y. So if my y is changing signs, that means I'm going up and down. I'm reflecting across the x-axis. So in this case, we would take our y's and we would change their signs. So it'd be x comma negative y. Here, notice your x is changing signs. So if my x is going from positive to negative or negative to positive, then I'm going to go back. I'm going to go left and right, which means it's a reflection across the y-axis. And so my x would change signs to negative x, y. Then some visual transformations. Here in example 1, it says, given the graph of the function y equals f of x below, sketch each transformation that results in the graph of g of x. All right, so they gave us f of x here, and they said g of x is going to be our f of x minus 5. Well, that minus 5 is not inside with x, which tells me it's going to affect my y's, and it says minus 5, so it just means we're going to go down 5. So this is just going to be a vertical translation down 5. And so that would affect my y's. So 1, 2. So I'm just going to count down 5. So that point, I'm going to pick this. Hold on. So first point I picked was right there, and I went down 5. Pick this one and go down 5. choose this one and go down 5. This one and go down 5. And then this one here and go down 5. And just re-sketch my graph. All right, so then g of x is equal to f of x minus 3. So remember, this is inside with x, so it's going to be it's going to be horizontal. It's being added or subtracted, so it's a translation. Now, horizontal translations are left to right. It says minus 3, so that means we're going to go to the right 3. So I'm going to take some points here, and I'm going to move them to the right 3. I'm going to go ahead and connect those. I'm afraid I'm going to get confused here. So I'm going to take this point right there and go to the right 3. This point down here to the right 3. And this point right here, I'm going to go to the right 3. So there's our graph, horizontal translated to the right 3. Now, on the next one, they threw in that 1/2. I'm going to take it out right now because we didn't talk about that number there. Okay, we hadn't talked about an A because that's not rigid. It's going to change the shape and the size of our graph. So just take out the 1/2, and so we have negative f of x. And so that negative is going to make us reflect. It says negative y, so that means my y's are changing signs, which means I would go across that x-axis. Reflect across x-axis. All right, so I'm going to go across the x-axis. I'm up here at, what is that, 6? So I'm going to go down to negative 6. Here I'm up at 6. I'm going to go down to negative 6. I'm just reflecting it. Here I'm on the x-axis, so if I reflect, it's going to stay on the x-axis. Oh, so sorry, this isn't working out too well. There we go. And then here I'm up at 4, so I'm going to reflect it to negative 4. And then there's just a reflection of that graph. And then g of x equals f of negative x. So now my x's are changing signs. So you look at the 2 circles I drew there. If my x's change signs, I'm going across that y-axis. So this is a reflection across the y-axis. I'm going to do the same thing. So I'll pick this point and I'm going to go across the y-axis. Just about at like negative 5. So I'm going to take it over to just about positive 5. This one's at x is negative 1, so it's going to be at positive 1. And then over here is at positive 2, so it's going to be over at negative 2. And down here is at 3, so it's going to move over to negative 3. All right, so there is our graphs. All right, then our non-rigid transformations. These are our stretch and shrink factors. They'll distort the shape of the graph. And so we get y equals a times f of x. Well, notice the a is not inside with x, so therefore it affects the y's. It's vertical. It's being multiplied, so it's a dilation. So it'll either be a stretch or a shrink. Shrinks are sometimes called compressions. Okay, you may have heard it as a compression before, okay? So if my a is greater than 1, remember when you multiply something by a number bigger than 1, it gets bigger, so it's a stretch. If you multiply by a number between 0 and 1, it makes it smaller, and so therefore it would be a shrink or a compression, okay? And it's going to be by a factor of, they say the absolute value of a, because if our a is negative, that doesn't matter. Remember, the negative is a reflection. It has its own job. And so our ordered pair y does what it's supposed to, so we would just take our x, comma, a times y. Or I like to write it as y times a. I always put my y value first. And then the same thing if it was a stretch. A shrink, excuse me. All right, for x. So the next two are y equals f of bx. It's inside with x, so therefore we know it's horizontal. It's being multiplied, so it's a dilation. But normally, remember, when we multiply by something greater than 1, it gets bigger. But with x, remember, everything does the opposite. So it's actually going to make it shrink. It's going to get smaller. And it's by a factor of 1 over b. It's going to be the reciprocal of the number, okay? And then the same thing here. Normally, we multiply it by a number between 0 and 1. It gets smaller. But remember, everything with x does the opposite. So therefore, it's going to stretch by a factor of... It's still 1 over b, but if you do 1 over a fraction, it does a reciprocal. So it's going to be the reciprocal of b, whatever it is, okay? And again, they put it in absolute value bars because, excuse me, they put it in absolute value bars because the negative will be a reflection. All right, so this says b times x. So we know, though, with x, everything does the opposite. So really, this is x divided by b, comma, y. And then the same thing here. It's going to be x divided by b, comma, y. But what you're going to notice on this one is your b is going to be a fraction, okay? So it comes out that it's actually going to be b times x usually. So, but I'm going to leave it as x over b. And we'll deal with that when we get there. All right, then example 2. Says the domain of a function y equals f of x is negative 6 to 8 inclusive, and the range of f is negative 3 to 7 inclusive. Find the domain and range of h where h is equal to 2 times f of x plus 1 minus 3. All right, so what we have here, when we look at our equation, is we can see, first thing I notice is inside with x, it says x plus 1. And so we know with x, we always do the opposite. And so we're really going to end up subtracting 1. But what we have here is that we're going to have our... All right, so... Well, one second. Let me look at something real quick. Okay, sorry, my answer key had a mistake in it here, and so when I looked over it, my numbers weren't jiving, so I had to see what was going on. Okay, so what it is for my f, we're going from negative 6 less than or equal to x less than or equal to 8. But we know for h, we're going to take our x's, and it says x plus 1, but with x, remember, we always do the opposite. So we're going to subtract 1. And so there is going to be the domain of h. All right, and we kind of do the same thing with our y's. Let me change colors here. So my y's were from negative 3 to 7. And this says we're going to multiply by 2 and subtract 3. And remember, y does what it's supposed to. It follows PEMDAS as well. So you're going to multiply by 2. And then you're going to subtract 3. And so there is our new range. Oops. All right, then example 3 says let the table below give values of the function k, add selected values of x. Let h of x equals 3k of 1/2 x plus 2. Find the following values. All right, so let's look at that. All right, so we got h of 2. So this is our x. Oh, don't have my pen on. So we're just going to plug in the 2 into our equation here, okay? So h of 2 equals 3k of 1/2 times 2 plus 2. So this is 3k of 1/2 times 2 is 1 plus 2. Now, I'm going to go find k of 1. So when x is 1, the k value is 3. So this is 3 times 3 plus 2, which is 11. All right, B, h of 0. So this is 3 times k of 1/2 times 0 plus 2. So 3k of 0 plus 2, go find k of 0. So it's 3 times k of 0 is 4 plus 2, which is 14. All right, I'm going to scoot well, no, I'm not. I'm just going to make do with where it's at. All right, then for h of 10, so this is 3k of 1/2 times 10 plus 2. So 3k of 5 plus 2, which is 3 times k of 5 is -4 plus 2, which is -10. And then the last one here, h of -6, is 3k of 1/2 times -6 plus 2, which is 3k of -3 plus 2, which is 3k of -3 is 0 plus 2, which is 2. All right, so example 4 says use the parent function for y equals f of x to describe how the graphs of each of the following functions g of x will be transformed. State the types of transformations in the graph of the function on the grid below. All right, so let me move this down a little bit. So let's look at A. It says f of x equals x squared, and g of x is equal to 2 times f of x plus 3. Not real sure why they put a square there. Typically doesn't go there, and then minus 4. So let's just look at the transformations first. So notice this 2 right here. It's not inside with x, so therefore we know it's vertical. It's being multiplied, so it's going to be a stretch or a shrink. When you multiply by 2, things get bigger, so it's going to be a stretch by a factor of 2. Then going across, I got this plus 3. It's inside with x, which means it's horizontal. It's being added or subtracted, so it's a translation. Horizontal translations go left or right. It's a plus 3, which you think would go to positive 3, but remember, x always is the opposite, so it's going to go left 3. And then the other thing we have here is a minus 4. It's not inside with x, so it's vertical. It's being added or subtracted, so it's a translation. Vertical translations go up or down, and they do what they're supposed to, so minus 4 would go down 4. All right, and so the easiest way on these is really using a table. So if you think about x squared, we know its vertex is at 0, 0. And so we could build ourselves a little table here. So if I do like -2 to +2, and I square each of these, there's my parent table. Now, when I go to do my transformation here, transformation, when I look on here, the only thing inside with x is a plus 3, which means we're going to do the opposite, so we're going to subtract 3. So take all of these x's and subtract 3. And then what's left is we have 2 times f, and then we have minus 4. So we're going to take 2 times our y and subtract 4. So we're going to multiply each of these times 2 and then subtract 4. And so because this is a 4 and this is a 4, they'll get the same answer. So multiply by 2, subtract 4, that's -2. And multiply by 2, subtract 4, that's -4. And so that will be our new graph. So we can go ahead and plot those points. And there's our graph of g of x. All right, when you look at b, it's going to be f of x equals x cubed. All right, and then g of x is equal to -1/2 f of x minus 3, again, that cube really should not be there, and then plus 1. So the negative, remember, it's going to be a reflection across the x-axis. The 1/2 is not with the x, so it's a vertical. When we multiply by 1/2, things get smaller, so it's a shrink or a compression by a factor of 1/2. The 3 is inside with x, so it's horizontal. It's being added or subtracted, so it's a translation. Horizontal translations go left to right. It's a minus 3, so we're going to go to the right 3. And then the plus 1 is not inside with x, so it's vertical. It's being added or subtracted, so it's a translation. It's a plus 1, so we're going up 1. All right, I'm going to use another parent table here to help me with my translation. So f of x cubed. I'm going to use those same x values, -2 to +2. And then I'm just going to cube each of those. Then I go to do my transformation table here. I notice with x, the only thing we have is x minus 3, which remember x is going to do the opposite. So add 3 to all of your numbers here. All your x's, excuse me. And then the y's, it says -1/2 times and plus 1. So I'm going to take -1/2 times my y and add 1. So I'm going to multiply all these by -1/2 and add 1. And then I'm just going to plot those points. So 1, 5, 2, 1.5, 3 is 1, 4 is 0.5, and 5 is -3. And then let's look back at your words. Did it reflect across the x-axis? Yes, it flipped upside down. Did it vertically shrink? Now, when you go from the top and the bottom and you shrink something down, you're squishing it down, so it's going to squish out, so it should have got wider. It did go to the right, and it went up. So we're good there. All right, example 5 says the function f of x is a domain of -5 to 5 and a range of -15 to 15. Function g is represented by the equation g of x equals -2 f of 1/3 times x plus 3 plus 7. Describe the transformations, then find the domain and the range of g of x. All right, so let's go through. So we see that negative. That negative just tells us it's a reflection across the x-axis. The 2, it's not inside with x, so it's vertical. It's being multiplied. Multiply by 2, things get bigger, so it's going to be a stretch by a factor of 2. Now that 1/3 is a horizontal dilation. It's horizontal because it's inside with x. It's a dilation because it's being multiplied by a factor of 1/3. Oops, hold on, somebody's at the door. All right, sorry about that. So let's see, we did the reflection across the x-axis from the negative. The 2 was the vertical stretch, or we could say a vertical dilation by a factor of 2. The 1/3 was a horizontal dilation by a factor of 1/3. The 3 is where we're at, so that 3 is inside with x, so we know that means it's horizontal. It's being added or subtracted, so it's a translation. Plus 3, so we're going to go to the left 3. And the plus 7 is not inside with x, so it's vertical. It's being added or subtracted, so it's a translation. Vertical translations go up or down. It's a plus 7, so we're going to go up 7. All right, so it told us that f of x had the domain of -5 to 5. And so they wrote it like that, but I'm going to do it like we did on the other one. And it had a range from negative 15, to 15. And so we can see with our x's, this is what's inside. So the parentheses is first, so we're going to subtract the 3. So it's negative 8 to 2. And then we're not going to multiply by 1/3. We're going to divide by 1/3, which is the same as multiplying by 3. So we get negative 24 to 6. And then for my range is my y's. That's going to be times the negative 2. Now I'm multiplying by negative, so technically my signs here switch. So negative 30. And then add 7. So we get 37 is greater than or equal to y, greater than or equal to negative 23. Or we can say negative 23 is less than or equal to y, less than or equal to 37. And so if we put it back in the same notation, my domain is going to be negative 24 to 6. And my range is going to be negative 23 to 37. Then some important observations. Transformations that occur inside the parentheses affect the x values of the graph and do the opposite of the expression. Talked about that. Transformations that occur outside the parentheses affect the y values of the graph. They do what they're supposed to. All right, then example 6 here says the function h is a continuous function that is defined on the closed interval from negative infinity to infinity. Use the graph to complete the table of h. Okay, on the axes provided below, sketch the entire graph of each transformation for h of x. Give the general rule for the behavior of the ordered pairs in the transformation. All right, so A says y is equal to negative h of x. So let me see if I can zoom out a little bit on this so we can see it a little better. Oops. All right, so, well, a little bit more. There we go. Now we can see, I think, enough there to help us. All right, so negative h of x, the negative's in front, so this is going to be a reflection across the x-axis. All right, and so that means my y's are just going to change signs. So I'm just going to make a table, and so my y's are times negative 1. So all those x's would stay the same that are up there, and the y's are just going to change signs. And I'm not going to remake it here. I'm just going to do this here. So this will be 6, 0, negative 5, negative 4, 0, 4, 5, 0, and negative 6. And the x's would stay the same. And so we can just plot those points. I mean, I think it might be easier to make the new table. All right, it should look like my graph just turned upside down, reflected across the x-axis. And it does. It was going down to the left. Now it's going up to the left. It's going up to the right. Now it's going down to the right. All right, B. So let me erase those points that we put in here. All right, B says h of negative x. Well, that just means my x's are going to change signs. So technically, because it says negative 1 times x, we would divide by negative 1, which means it's going to be the same. So this would become positive 2.5, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, and negative 4.5. Okay, and so we can just plot those points. And so it looked like our graph should just switch from the left and the right. Okay, can't really tell much of a difference in the graph from A because the points are so close. All right, C has h of 2x. That 2 is inside with x, so this is going to be the horizontal dilation by a factor of the reciprocal, so 1/2. And so when I go to do my table, I'm just going to take my x's, not times 2, but the opposite, which is divide by 2. So I'm going to take all of my x values, and I'm just going to divide them by 2 or multiply by the 1/2. All right, so let's see, divide by 2, divide by 2, divide by 2, divide by 2, by 2, by 2, by 2, by 2, and by 2. And then we can plot those points. All right, and so we had a horizontal compression, which means I'm going to squish it in from the left and the right because it's horizontal, so it should make it more narrow, and it did. And then D, again, it's inside with x, so it's horizontal. It's being multiplied, so it's a dilation by the reciprocal, so by 2. And so this one, if it's by 2, that means we're going to horizontally stretch this. And so if you take the left and the right and you stretch that graph out, it's going to cause it to get wider. So I expected to see it get wider. And for my tables, this says 1/2 times x. We know that's x divided by 1/2, which is the same as x times 2. So now we're going to take all of our x's and we're going to multiply them by 2. And then my 9 is off the graph, but it's just barely off the graph, so I can make that work. And so it does appear that we took our graph and we pulled it from the left and right and stretched it out. Now, when you compare it back to the original graph, you got to be a little careful because notice the scale of our axis is different, okay? In the original graph there, it only goes from -5 to 6. And here it's going from -8 to +8. Oops, sorry, wrong one. -8 to +8 right there. So they changed it a little bit, so it's harder to eyeball it, but it did stretch. All right, and that is it for 12A.